All right, so our notes on this week are going to feel very similar from last week. We're still talking about slope and y-intercept. For our vocabulary, we have slope, y-intercept, rate of change, initial value. What is slope?
The rate of change.
Rate of change, which is
Rate of
the rise over run on a graph, right? But whenever we talk about ordered pairs, it's the change in the y over how the x is changing, right? So slope's no different. All right, and what about y-intercept? How would you discuss y-intercept?
the point where it crosses the x.
Okay. So where a graph crosses, it's the y-axis, right?
Well, I don't know.
But it's where x is equal to what?
Yeah.
X is equal to 0.
Same thing. Y 0.
It's where x is equal to 0.
Same thing.
Stop saying the same thing, it ain't.
All right, and so we keep saying, well, slope is like a rate of change. What is rate of change?
Slope.
Okay, we could say rate of change is slope, but rate of change has a more specific answer. Yes?
Distance from one point to the next.
Okay, the difference from one point to the next is a good way to think about it. It's a rate. Okay, it describes one change to another, like miles per gallon or miles per hour, dollars per hour, where you're taking the rate of change of one thing and comparing it to the rate of how something else is changing at the same time. Initial value, what is initial value?
The y-intercept.
It is the y-intercept. That's where we would find the initial value. The initial value would be our starting value, right?
Mm-hmm.
So it's kind of like if you wanted to know what it would be like in like a math word problem, you would talk about like a membership fee to a gym. You have a monthly membership, but then to join the gym you have a membership fee. That one-time charge is your starting value because you're going to pay that regardless of how long you keep that membership. It's not the rate of change. Looking at our examples, so this is an example of an equation. So what is the slope of this first equation? And what is the y-intercept? -4. And so we're very familiar with this because if you look over here, this graphic is this third time we've seen this. What is M representing here? Slope. And what is B representing? Y-intercept. Okay. The big idea from this is that slope is always with the x value. It's with a variable. The intercept is going to be the constant, the number without a variable. Okay, so what is the second equation? Slope. And the y-intercept? All right, and looking at a table, so we're going to focus on identifying slope and intercept from an equation, and a table, and a graph, and now from words. So if we look at a table, how do we find the slope?
Subtract the first x value and the second one, the first y value, the second y value.
Yeah, so take y2 minus y1 over x2 minus x1, right? We're kind of working backwards, second to first. So what is -12 minus -6? -6, okay. And then what is 0 minus -2? +2. And so -6 over 2 is what? Negative 3. So the slope is negative 3. Where's our y-intercept located on a chart?
Where x equals 0.
Where x is equal to 0. So what is the y-intercept here? Negative 12. So you might find out that this week actually is a little easier than last week. Looking at the next table, go ahead and try to find the slope and the intercept. Don't let it trick you. Remember, it's the change in y over the change in x.
Okay. I got it.
You got it? So the change in y values, you should have taken 0 minus 2 over,
7 minus -7 minus -6.
wrong direction, negative 6 minus negative 7. Second minus the first. Okay, so 0 minus 2 is just negative 2. Negative 6 minus negative 7 is 1. And so our slope is actually what simplified? Negative 2. What is the y-intercept? Anybody have it? 10. Positive 10 or negative 10? Positive 10? Some people said negative 10.
Negative.
Okay, so how would you figure out where the y-intercept is on this chart?
Where x equals 0, so it's negative.
You know what? You have to work backwards.
Okay, you can work backwards. So for this one, we have negative 7, negative 6, negative 5, negative 4. If we keep going, it'd be negative 3, negative 2, negative 1, and then there's 0, right? Okay, and then from there, we're just extending our table at this point.
12. Okay.
That's what I said.
Yeah, so these are decreasing by 2. So negative 4, then it's negative 6, negative 8, negative 10, negative 12. Very good.
I just stopped at 1.
You stopped at 1. Okay, yeah. Make sure that you stop where x is equal to 0. Okay. For the graph, if you look at the graph, the y-intercept is always the easiest to find because it's where it's crossing the y-axis. Where is it crossing the y-axis here?
1.
Okay, at positive 1. Okay, now from there, and I want you to draw this on your graph, okay? Mark the intercept with a point. And where's the next whole number point at?
2.
Okay. You could go 2, 2, or you could go negative 2, 0, right? Either one is fine. But what is the rise and run here?
Over 2.
Rise 1 over 2.
So it's up 1 over 2. Make sure that you label it like that because that is how you find the rise over the run. And 1 over 2 is just 1/2, right? So your slope is 1/2. Can you repeat that process? That's how you could check yourself. Can you go up 1 over 2 and pick and land on another point?
Yeah.
Does it land on line? Yeah. And so it's going to continue that pattern. Okay, so you should be able to do those stair steps the whole way up the line. So you should even be able to go backwards. So you should be able to go back 2, down 1, all the way down the line. That's how you check to make sure you have the right slope. All right, looking at the next graph. What is the y-intercept here? Negative 1. Okay. And what is our, well, where's our next whole number point going to be?
1, -4.
Okay, so 1, negative 4 is right here, crosses exactly. And so now we can find the slope. We know that this is a negative slope because it is decreasing, but we went down how far? 1, 2, I only went down 3. Are you sure it was 4?
Oh, yeah. 3.
Okay, so down 3 and over how far?
1.
1. So this is actually just a slope of negative 3. Now make sure that you can repeat that pattern, right? So it would be back 1, up 3, and it still works. It still hits that line exactly where we would want it to, right? All right. Now, looking at our words. A plumber charges $50 to make a house call and $25 per hour for labor. Okay, so you need to decide which one is the slope and which one is the y-intercept. So in other words, which one's the initial value and which one is the rate of change? What is his rate?
25.
How do you know?
Because 25 per hour.
Yeah, because it says per hour. That means that it's what he charges hourly.